Okay, now we're going to talk about how to find a polynomial of lowest degree and real coefficients given the following zeros. So in this particular case, I want to talk about if we're given 2 plus I as a 0, and we're also given -3, but they give us a little more information on this. They say -3, but then they also say that that -3 has a multiplicity of 2. Now, a quick review of multiplicity. Multiplicity really references graphically how the graph will act at that 0. So, for example, in this case, at the 0 of -3, the graph is only going to touch the x-axis at that point. It's not going to cross. It's going to essentially bounce off the x-axis at -3. So you might have heard of it as a double root. That's another way that some teachers explain it. It's a double root at -3. So the first thing we want to do is we're going to go back to the conjugate pairs theorem and say, all right, if 2 plus I is a 0, we know 2 minus I must be a 0. Okay? So address that initially. Now, I'm going to revisit what I had talked about earlier in a previous tutorial, which is if you have imaginary zeros, how can you quickly create the polynomial with that x squared minus the sum plus the product shortcut? So let's revisit that for just a minute. So remember, I need to find the sum and I need to find the product of those zeros. So if I add them, I get 4. If I multiply them, let's see what we get. Remember, we just multiply straight down because since they're conjugates, the middle terms will cancel. So I have 4 minus I squared, which generates positive 5 because negative I squared will become plus 1. So what I've just created there is the polynomial x squared minus 4x. Oh, sorry about that. Let me rewrite that. So x squared minus 4x plus 5. Again, take a look back at the explanation of x squared minus the sum plus the product if you're unsure about that. So I've taken care of these two, so I'm going to pull a check here. But now I have to address the -3. If -3 is a 0, that means that x plus 3 is the factor. And if the multiplicity is 2, which it is here, that means that I need to raise that factor to a power of 2. Okay, so again, the multiplicity is going to be reflected in that power outside the factor. So if it was a multiplicity of 3, I would need to put a 3 on the outside. Now, depending on how far you're being asked to go, in some cases you can leave it right here. Just put f of x at the front and you're good. But if they want you to multiply it out, unfortunately, you got to do that, which can be a little painful. So if you were asked to multiply it out, I would leave the first polynomial alone initially. So x squared minus 4x plus 5. Oh boy, alright, hold on. That looks awful. So minus 4x plus 5. And I'm going to FOIL the x plus 3 squared. So x squared plus 6x plus 9. Please don't say that that's just x squared plus 9. That would be wrong, so please don't do that. Alright, now we have a trinomial and a trinomial being multiplied, which means it's going to be pretty ugly. You got to multiply every term from one polynomial by every term in the other one. So I'm going to start with the x squared at the front. So I'm going to get x to the 4th, and I'll show you how I like to do this. Get x to the 4th plus 6x to the 3rd plus 9x squared. Alright, so that takes care of that, guys. So I'm going to put a little check. Now I'm going to go to the middle term, the -4x. -4x times x squared is -4x squared. Go to the middle, -4 times 6 is going to be -24, and it's going to be x squared. Notice how I'm lining up the like terms, and the last term is going to give me negative 36x. So now I'm done with the middle. Now I go to the 5, and I get 5x squared, positive. Go to the middle, 5 times 6x is 30x. And then I go to the back, 5 and 9 is 45. And I like this technique. This is essentially a vertical technique because it lines up everything. Okay, so now when I go to put it all together, I can just go straight down. So my function is equal to x to the 4th plus 2x to the 3rd. What is that? 9 and negative 24 is negative 15 plus 5 is negative 10. I apologize if that's wrong, but I think that's good. And then I get minus 6x plus 45. So we have created the polynomial which has zeros of 2 plus I, 2 minus I, and negative 3 with a multiplicity of 2.